Welcome students. Today we study valence bond theory, which explains the bonding in coordination compound. It is said to be the first attempt to explain the nature of bonding in coordination compounds. Now, when we talk about the nature of bonding in coordination compounds, according to valence bond theory, the bonds between the central metal atom and the ligands are said to be the coordinate bonds, where the electrons are provided by the ligand. Now, come to the assumptions of this theory here. It says central metal atom provides vacant orbitals. These vacant orbitals undergo hybridization as per requirement. These vacant hybrid orbitals then overlap with the orbitals of the ligands. Hund's rule is strictly followed. However, under the influence of strong ligands, electrons may pair up. Now, this theory also predicts the magnetic property of complexes. According to this theory, if a complex has one or more unpaired electrons, it is said to be paramagnetic, and if all the electrons are paired, the complex is said to be dimagnetic. Now we'll take the example of octahedral complexes. You know, octahedral complexes have coordination number 6. That is, 6 ligands are attached to the central metal atom. Okay. Now these octahedral complexes are again of two types: inner orbital complexes and outer orbital complexes. Now, as the name itself suggests, inner orbital complexes in which the inner d orbital participates in bonding, and these are also referred to as low spin complexes. Outer orbital complexes are the complexes in which the outer d orbital participates in bonding, and these are also known as high spin complexes. Now let us take the example. We start with this first one. This is hexacyanidopherrate 2 ion. The central metal atom here is iron, ligand is cyano, and coordination number is 6. Now, atomic number of iron is 26. So, when you write down the electronic configuration, we write this as 3d6, 4s2, 4p0. I'm talking about the valence shell electronic configuration. Now, when we calculate the oxidation state of Fe here, okay, this comes out to be +2. Now, why +2? We assume the oxidation state of Fe to be X. Okay, cyano is a negative ligand with oxidation state -1. 6 will make it -6. Okay, is equal to the charge carried by the complex, that is -4. So this gives the oxidation state of Fe to be +2. +2 means 2 electrons from 4s orbital have been removed. So now the electronic configuration becomes 3d6, 4s0, 4p0. Now this ligand here, the cyanido ligand, is a strong ligand. So this forces the electron in 3d orbital of iron to pair up. Okay, so under the influence of this cyanido ligand, the electrons pair up. Now, 2 vacant d orbital, 1s and 3p orbital intermix together to redistribute their energies and form 6 d2sp3 hybrid orbitals. Now, these 6 d2sp3 hybrid orbitals overlap with 6 cyanido ligands to form the bonds. Okay, so this is the complex which involves the inner d orbital, that is d2sp3 hybridization, and hence is referred to as low spin complex. Now, if you see the number of unpaired electrons in this complex, okay, all the electrons are paired up. So this complex is dimagnetic in nature. Coming to the structure of this complex, okay, as we are saying that it is an octahedral complex. So the structure is like this. Okay, Fe and 4 cyanide ligands in one plane, one above and one below the plane. Okay, and this all is enclosed within square brackets. And here is the charge written. Okay, so this is the structure for hexacyanidopherrate 2 ion. Now we come to this complex of cobalt. Okay, this is hexafluoridocobaltate 3rd ion. Now in this particular complex, again we see the central metal atom is cobalt. So we write down the atomic number, that is 27. The electronic configuration will be 3d7, 4s2, 4p0. Okay. Now in this particular complex, fluorido ligand is a weak field ligand. So it cannot force the electrons present in the d orbital to pair up. Okay, so in this particular case, the outer d orbital participates in bonding. Now, if you see this particular complex, we calculate the oxidation state of cobalt, which is +3. +3 means 3 electrons will be removed, 2 from this 4s, 1 from 3d. So now the configuration is 3d6, 4s0, 4p0. Okay. Now this 3d orbital is not involved in bonding. Outer 4d orbital participates in bonding. Okay, so under the influence of this ligand, now 1s, 3p and 2d orbitals, they intermix and redistribute their energies to form 6 sp3d2 hybrid orbitals. Now these 6 sp3d2 hybrid orbitals overlap with 6 fluorido ligand to form the complex hexafluoridocobaltate third. Now if you see the number of unpaired electrons in this particular complex, it is 1, 2, 3, 4. So this is paramagnetic in nature. Coming to the structure again, it is octahedral complex. So again the central metal atom, that is cobalt, and 4 fluorido ions or fluorido ligands will be in one plane, and one above the plane, one below the plane. All this enclosed within square bracket, and this 3 negative represents the charge carried by the complex.